The presentation now will be presented by Jan Spindler, our head of our MPS EMC lab here in Germany, and he will present about practical and early testing showcases.
Thank you, Julian, for introduction, and thank you for being here, for joining online seminar. It is for us one big chance to show you a little bit what we've done during the last years, where we had only maybe some webinars or some smaller activities, and here maybe we try to bring one bigger. And what my presentation will be the start to getting more and more to some specific topics maybe we have on DC-DC design, and maybe later to other topics we will have from Arturo and Jens, which follow later today. So this slide, or the next two slides I've shown, I think everybody of us seen this several times, maybe from different point of views, and everybody's saying, hey, EMI, it's important. But nevertheless, I think it's not often enough to say this, because every time you get in discussion about what's the problem, why do we do it, and especially also the costs. And what I want to see, based on my experience on the past, when I started at an EMC lab only to testing, doing it for tier 1 applications, and then at the OEM as well, I've seen there are really problems on this. So it's not only magic, what you're saying, hey, the guys are crazy, we need to fulfill limits, we need to fulfill this level of disturbance. Yeah, no, there are really topics you have in the real life, yeah, which affect your function of your design of your product. Yeah, that's really happened, and it doesn't happen if you take care about EMI. And this is what you need to know. Yeah, because when you sell your product and it's in the field, and you never get requests based on worst EMI or something like this, everybody's saying, hey, why we are doing this, we have no problems. Yeah, but we have no problems because we did it. Yeah, that means if you talk about the EMI, that means you talk about a product which needs to work in the rough environment we have. We have more and more frequencies, we have more and more services, online services we need to work. Everything is much closer. If you look to this room, if you look to your home, yeah, you have everything wireless working, you have high power, you want to have great distances. So that means there is something, yeah, and it's a real fact that it cannot work, yeah, what you design. And the other thing is, yeah, to regulate this, we need to improve our products, that not everybody can make what they want. So that means we are always in a discussion between, yeah, our product needs to be robust, but our product needs to be regulated in case of emissions as well, because otherwise the whole system doesn't work. Yeah, if you look in the past, especially for the car makers, it was a big topic for plug-in hybrid or electrical EV car. You have something you can plug to the environment, to a traditional AC network. Yeah, it was a big challenge, because in this case you have different regulations, yeah, on this as well. You need to take care about. Before, if you were an OEM, a car maker, yeah, you have a car, you need to take about your car, you have ECE R10 regulation to certify this, and then you have your services inside the car, and everything was fine. Now you plug it to a different network, yeah, and also the topic, you have infrastructure on the street which is plugged to the car as well, and this interference between this was a big topic, and I can say it doesn't work in the beginning. It was a big problem to get this running. Yeah? That means from a functional point of view, yes, this is important. Yeah. From an economic point of view, it's also important, because worst EMI results have an effect to your success of your product, and in the end also of the whole company, because you want to sell products to be successful. It's a basic of, if you are a production company, you make a product, you want to sell it. But to sell it, you need to fulfill the EMI requirements. That means this doesn't work, only this or this. And taking care about all the EMI is essential to be long-term successful. I believe on this, because otherwise you have the cost problem on your topic, and you need to be realistic at the beginning that that comes to you. If you don't have this in your mind at the beginning, you will remember on this in the end of the development. And I think what we are all engineers are focusing, and what we learned during all our study, our work, is always to find a compromise between all these topics like cost, fast time to market, so fast development times, fulfilling requirements. So it's in our mind, I think, to find always the compromise. And if we say, hey, it's important to do EMI, it's not because we want to say, hey, I'm important. No, we want to say, we learned that it's important, and we are willing to find the best compromise between products. And I believe when we start this EMI topic from the beginning, it doesn't matter. It doesn't mention that that the costs increase over the whole project. I think always you are much more possible to get a cost in a range, in a certain range. You can define at the beginning, because this is something, what I say, you need to be realistic on this. And that's why the question is, how does become EMC, EMI a success factor for your project? Because now I want to turn this bad, EMI is bad. When I started at my first job, my boss asked me, why do you want to make EMI? I said, because for me, it's very interesting, and I see big chance on this. Because all you measure and what you find out, nobody wants to know, because it's always bad information. And then I said to me, okay, we need to change the mind on the managers as well. And we say, how does become EMI, EMC a success factor for us? Because we know it, we know we need to fulfill it, and now we need to find the way how we get it to a success for us. Because in the end, we need to fulfill it. And that means we heard a lot from Arturo and now from Christian as well. We need to understand at the first step the background about it. Why do we need EMI? What's important on this? What are the requirements of your product? It's sometimes often okay. Because this is often a question at the beginning. You want to develop, you run forward, you have your function, but you don't know what to fulfill. As you know, from the automotive perspective, you have different OEMs and with different standards. So that means always there are some special features on the standards. You need to take care about this as well. And one important thing is also the test plan. Because on the automotive side, on the tier 1s, tier 2s, it's often clear that you need a test plan which is synchronized with your customer. But we have also some smaller customers, some industrial. What I say also, please think about a test plan. Think about what you want to do to have a good overview over this. The other thing, as Arturo mentioned, beginning from starting the whole the EMI at the beginning of your development means also EMI on a mechanical and electrical concept. Arturo did shown some foils on this as well, because I think that's quite good. What I want to go more in deep with my slides is this conduct pre-tests, not like Christian did, with more or less with the products you need. I want to show a little bit more in direction of choosing the right switching frequencies in point of thermal view, or what is, because there's always a pro and cons on this as well. Yeah. The other thing is this structured development process. It means be realistic, be clear, you need it, yeah, and then think in the future and not in the past. Yeah. Yeah. What I want to say, you're in the first measurements in the lab. Maybe you have not the result you expect, your worst result, and then you start to optimize something, but you have no place on the board. You cannot try something, or it takes a lot of time to modify your board, to check something, additional components and so on. So that's why we often see maybe it's maybe good in the first step to have some placement options, some room where you can put a cap or something else in. Yeah. And what I want to talk about a little bit more is also the planning of the EMC test during the development with testing loops. Yeah. This is, let's see, check how it is and how the EMI work in the real world. Also here placements, mechanical, what Arturo mentioned, and also the test plan. Yeah. Yeah. What I want to say with the conduct pre-testing, yeah, as mentioned, not everybody has the possibility in his own company to do the EMI testing, but sometimes it helps also to do some A/B comparisons of some effects. The other thing, what is, you have your suppliers. Yeah, you can talk with them as well. Maybe they have some experience on this as well, or they can help you. Yeah, because they know the product. Yeah, especially when I'm talking about MPS and talking about us. Yeah, we try to figure that out on our evaluation board. What are maybe some points you can work with and you can change something. Yeah, that's clear. That's every time a pro and con. You need to add additional component. You need to get a higher thermal behavior or something like this. But this is something I think it's quite important to see, yeah, because you have a lot of things to do during your day, yeah, and it's not only the DC-DC converter what you need to take care about. That's why we think this would be an important help for you during your development, yeah. And also the option of evaluation board and first prototypes to get a feeling, especially before you go to a lab or external lab where you need to pay money. Yeah, it would be good if you have a feeling about what you have in your hands, yeah, and understand what you are doing on this. Yeah, planning the tests, yeah, as mentioned, leave room for filterings maybe in the first state. Later, it's not necessary. It's all about what we're saying is also about cost reductions. Yeah, in the end, what we are making quite often is, yeah, we're starting with the development. We put maybe some additional components, and then we try to reduce the BOM. But we can also only make the decision how big your BOM and what components you need if you have the real application on your side, yeah, because before on the schematic and so it's hard to say. So it's always depending also on the layout, because as Arturo said, you have a lot of things which makes the EMI as it is as a whole system. Yeah, it's not only the schematic, it's not only the layout, it's not only the housing or something like this, it's the whole system on this. Yeah, and also what we see quite often is get in touch with your labs to discuss, to be well prepared in the whole process. Yeah, it means checklist, yes, but checklist is for everyone a little bit different. But I think these are some essential points what we see quite often. You go to the lab and then you say, hey, we need a BCN adapter. And they say, oh, okay, no, we don't have it, huh? Or we have this not. So your expectations to the labs and the lab to you, this is something you need to clarify. talk with each other, make this. This sounds quite easy, but I've seen it so often that this is a problem, and you spend hours preparing this on the lab because you didn't talk before about your problems. Yeah. And yeah, as mentioned quite often now, be realistic, planning test loops to improve the product during stages. That means not doing test labs because you have such a worst result. Also test loops to improve the BOM, improve the costs. Yeah, trying something. Yeah, some improvements. And this is what I want to say initial. Yeah, it's not EMI. It's not only cost. It's only something you can optimize. Yeah, your product on this. Yeah, I think on the one hand, it's not good to have too much filtering, too much too big caps, too much from everything. It makes no sense, because then you are not successful. Yeah, because your product you cannot sell on the market. Yeah, and the other thing is, if you have too less, you cannot fulfill the requirements. So that's why we try to get always to optimize on this. Yeah, and also some simple things, but I think you quite often see. Yeah, bring data sheets, schematic, layout together to the EMC lab to be fast. When you see the problem, you can react on this. You can discuss. You can put it on the walls. You can draw inside something. You can work. You can be creative on this. Yeah. Reference boards from old measurements. Always a topic. You have a new board. You put it in the chamber. You say, "Oh, it looks totally different. It's not like you expected." And then you ask, maybe, can we try the board from last time? Yeah. Oh no, this board doesn't exist. And then you start again. Yeah, saying, okay, analyzing what did you change, what modifications is between the boards, and then you maybe thinking about, this could be the reason, this could be the reason, but you never know. Yeah. Maybe there's also a fault in the test setup, also possible. Yeah. And also take spare parts with you and alternative components. This is something maybe we will discuss later today and so on. And I have a foil as well, especially for the inductors. You have some possibilities for the capacitors. Yeah, where you say, okay, we have different suppliers, maybe we can change another supplier, maybe we can change this and so on, because it's not everything is the same. Inductor is not an inductor. Yeah, and you have different vendors, and you see also the different constructions. You see quite often different performance. Yeah, on the EMI as well. It's not only I'm not talking about all the function and all the DCR losses and so on. This is not what I'm talking about. I'm talking about the EMI in this case. Yeah, and prepare the test setup in your company as well. Yeah, build it up. You need to understand, if you are in the EMC lab, you are the guy who need to advise the lab stuff. Yeah, as well. Now I want to, then you have your test plan, you know what you need, but then you're starting next, okay, where I want to start. Yeah, we have several test methods. This is from the automotive point of view. Yeah? You have conducted voltage method, current probe, radiated testing, strip line, BCI, antenna. So you have a lot of testing, but now you want to know where to start when you have your first prototype. And what I try to do now with this presentation, I want to show you maybe two measurement methods where I say you can get a very good overview with a certain effort you need. There's always an effort, yeah, that's clear. But I want to go maybe to show a little bit with which methods you can get a certain result where we can start and improve. Yeah, so it's always the starting point on this. Yeah, when I look to the conducted emission, the setup we see in the presentation, it's quite simple. Yeah, you have your product, you have a listen, you have cable, you have a receiver, oscilloscope, spectrum analyzer, whatever you have. Yeah, that doesn't matter in this case, yeah. But it gives you a good overview, maybe up to 110 megahertz. You see it, but in point of view for our DC-DC converters, it's one of the most important frequency ranges. Yeah, we have measurement is quite fast. The effort is it's quite okay. It's not so big to do it, and you can do it with a pre-compliant setup. Very good. Yeah, you don't need a shielded chamber. You don't need a full compliance measurement thing. You don't need software as well to make this testing. Yeah, and I try to figure out what are you focusing, yeah, with this measurement. And when I say you have a whole system, I try to say, okay, what picture you can get from this measurement. And what I'm thinking, you get a good overview about your layout, yeah, with this measurement. The input filter will be later important as well for all the conducted immunity testing, but here quite good as well. And here you see quite often, depending on your switching frequency, optimizations as well, yeah, for the components. What I'm saying, alternative components, changing something, changing suppliers. You can figure out, yeah, housing, yes, in terms of shielding, maybe something like this, but maybe in this case, it's not the primary thing, yeah. I sum up here maybe a board, evaluation board from us to see what you can do with this measurement. And as mentioned here, I've separated in this 5 topics, yeah. And then we did some changes, yeah. We're starting from the green one here, where it was our initial setup, from our EVB, yeah. Then starting something like this, sometimes you see a dot on your inductor, yeah. The dot has normally something to say. It's the start of winding, yeah. And what we figure out during the last years, and I think Jens talking about this since 5 or 6 or 7 years, yeah. Unless, yeah, we need to understand this. It's quite some constructions of the inductor has an effort. Yeah, that means if you turn the coil here to the start of winding, which needs to be in direction of this switching node, you get improvement. Yeah, you don't see it here at this measurement so good, but later when we look at the measurement for the higher frequency range FM band, then you see the effect. Then we switched the main coil to another supplier. Yeah, we reduced the loops and traces. So we did a change on the layout. Then we modified a little bit the input filter. Yeah, and this is what we see here. We are switching here as a 400 kilohertz with spectrum. So now we are below this middle wave band. Yeah, and here we have a little bit room. Yeah. To optimize the filter in case of the costs of the filter. Yeah, so this is something here, maybe a cost optimization, yeah, on this point. And then we did also some modifications on the layout by changing the positions of the CR. I think Frances and Xavier later from our Barcelona application team will show you there some more things about this. And now the same measurement, the same board, only the other frequency range here. You see much more effects. Yeah, when you're starting from the green one, then we turned the main coil. Yeah, you see here we win 3 dB. Yeah, only quite simple, no additional cost, nothing. Yeah, on this, only checking the dot, start of winding, and it's clear. So depending on the concept of the coil, yeah, some has you have a bigger effect, some has no effect on this, but this is something you can check, yeah, quite easy, yeah, on this. Then we changed to a different coil, yeah. See also an improvement. There's also, it depends on the on your main coil you have, or inductor you have, maybe, but this can be something as well, because if you look also to our evaluation boards, you often see a quite big inductor. And if you think about your application in the end, maybe you can say, I don't need this one, maybe I need a smaller one. And what Arturo mentioned before, and Jens will go more in detail as well, is the size of the inductor is a big impact of your, and this is something you need to discuss with your supplier or on your own to optimize the inductor in case of size and maybe of the type of your inductor. And then you see also layout, and it's quite simple things. It was not going from a 2-layer to a 4-layer or something like this. It is quite simple changes we did here on our board, and also the see out, because it's the load is always with the evaluation boards. We have a big topic, because you in your application have normally the load is on your board. When we're testing with our evaluation boards, we have a separate load, and this is quite difficult to do this, because it works always like an antenna on this. The next thing is what we see during the last days, during the last months, more and more, is this topic with the C-in capacitors. Especially if you have, when you have more than one switching regulator on one power rail, and they are switching different. So last time we had a board with, I think, more than 20 switching regulators in the application. And then you see always when someone is switching, they need a current, they need a power, and they get it where a capacitor is sitting. And if your own capacitor is not big enough and the size is not existing, then you create a current flow you cannot handle. So that means always thinking about something like this. And what you see here is especially some of this effect without this C-ins, which are where the position is quite important and the size is quite important as well for the DC. You generate a current. You don't want to know where it is, so it means also you want to have this loops quite small, and you see this big effect. So it means also here is a topic you can work on this. The next topic, radiated immunity. Yes, that's a little bit it's a little bit more effort, and it's quite not so easy to do it in a pre-compliant setup, like this. But maybe you have some possibilities with what I mentioned before, is mobile transmitter testing or something like this, where you don't need such a big amplifiers and so on to test this. But this is also a quite good method to get an overview about the robustness of your DUT. But additionally, not only the amplifiers is the big problem, it's also all the monitoring on this, depending on your application. And this is also something you need to take care about. When you're going to the lab, you need a certain method to monitor your device, to say at the end, when you do the test, during the whole test, your device is still works as expected and in normal modus. This is something you mentioned, and it's a big effort for you and for the lab, to get this. In an industrial, the industrial, maybe it's sometimes enough to monitor with a camera, but for the automotive, with all the simulations and so on and the communication, maybe it's much bigger effort to do this. It means work, and this is something you need to take care and prepare as well. And this is now not a measurement from the radiated immunity testing, but this is something before. If you talk about immunity, as you know, we're focusing more and more also in direction of IC level testing. Yeah, and this is a measurement we did with a certain IC, from us, to show you a little bit why is this immunity topic and the layout also important and what can happen, and why we doing this. In the end, it's quite easy. We want to see which pins are sensitive and what are we doing with this information. On the one hand, we cannot get every pin of the IC to a certain level because the function of the pin is to be sensitive. They need to react on small changes. It's not possible to block here everything. That means in the end, you when you do the layout, you need to take care about these pins and about these traces. For example, don't route it on the top layer, on the bottom layer, put it in the inner layer. Take care about your length of the traces and so on. This is something what we learn, that we learn more out of this than maybe improving a whole IC to get it in a certain status. In the end, this is a result you can quite easy implement, or sometimes you can quite easy implement it to your layout as well. If you have such informations about this, or we can give you this information, what are the sensitive pins you need to take care about. It makes much quite easier on this as well. And all these topics is a little bit the base on why we did all this, why we doing the seminars, or we're trying to get more and more seminars, and we built this lab to work more and more on these topics, to give you advice on the ICs, and also to give you room and give all the engineers room to work on his topics. Because, getting back now to the beginning, if we take care about EMI, we are able to be successful for long term. Means if our customers have success, then we participate on this as well. Because if you sell more, we can sell more. It's quite easy. And what we did for this, I did this slide for the people which are not here, who cannot be here, to show a little bit why we try to get further with our work. Is we built this lab for the industrial with a 3-meter chamber, with automotive chambers, and full compliance with a shielded chamber for analyzers, automotive test pulses, and electrical testing as well, which is quite important for us. And also all the industrial pulse testing, this is not installed, but it is in plan. And I hope that's a little bit what we can say. Practical means, for me, practical, you can do it tomorrow. You can do it now. You don't need expensive equipment. You can. I hope you have some points out of the presentation you can use for tomorrow without any invest. Then thank you.
So now let's get started with the first question. Do we have any question from the audience here in the room?
Question to the slide where you showed the robustness of the pins, so the unity robustness of this one. How is this to understand? Is it a classification? How robust is one pin against external disturbances? So, is there something like a level? When the level is reached, then there's a malfunction, or
exactly. You increase the power to one pin, and then this line shows which at which level you get a abnormal function. Yeah, that the V out is changing, or the switching or turned off, or something like this. And that means here with a quite lower level, you get here at this pin, you get a reaction. Yeah, and that's what you say, it's the abnormal function. Yeah, function on this, and you see, and there's always a limit. Yeah, on this end.
Then you would say on the E7,
Yes,
brown one,
exactly.
okay, on this one I should be the most sensitive and should be very
Careful with the routing on this. Yes. Yeah, the question was how to understand this diagram. Yeah, what was the main question? And as mentioned, it we draw here. We put here to a certain pin of the IC a certain level. Yeah, and depending on the level, we checked out the function of the IC, the overall function. Yeah, and if we increase here, for example, with the IZ pin, we increase the level, and then we get an abnormal function on a certain level. And you see here a little bit the sensitivity of each pin. Yeah. But then
your last slide, you showed your infrastructure in your EMC lab.
Yeah.
You showed that you own a 6x25 chamber and also a 3-meter semi-mechanical. Can you comment shortly in just a few sentences what are the difference between
okay.
chambers?
Yeah, okay. The question was, what's the difference between the two chambers, for example, the 3-meter chamber and the automotive chamber? One of the main difference is the size. The size is based on the problem that the automotive chamber, for example, is more constructed for efficient. That means they try to make it small as possible, because our the products, the automotive products, normally, I'm not talking about now all the EV stuff and so on, but the normal parts are quite small. That means you need a smaller chamber. Additionally, you don't need to move the antenna. So that means you have always this 1 meter measurements distance, and you don't need to move the height. And additionally, you have, like here on the picture on the bottom, is you have this metallic ground plane or table with a metallic ground plane. This is one main topics. Yeah, compared to the industrial chamber or the 3-meter chamber, we're talking about much bigger DOTs. Yeah, and in this case, our chamber is built for 2 meter. A cylinder of 2 meter, so it means the product can be so big to be full compliant on this. Yeah, and then you need to see the whole DOT. You need to get with the antenna higher distance to see the whole product, and that's why you're talking here about the 3-meter topic. Yeah, on this, and as you see here is you have no wooden table with a metallic ground plane. You have a plastic stir-door table, yeah, where you can place a DOT, which is a tabletop. And if you don't have a tabletop like a wash machine or something like this, you place it directly under. So that, and then additionally, you have a much higher height to move the antenna to find the points, and you have a turntable inside as well. So, but for you. For all the hour here, we can make a lab tour now during the dinner to get in more detail about this.
The intention of this lab is to make the MPS IC measurements, or also open for the external customers?
Yeah, we have 3 main topics we want to focus. One topic is our ICs and improve our ICs, working on our products and improve our overall know-how. The second thing is we want to work with you as our customers. Yeah, that means we want to work with you, improving projects, optimizing projects. It's this for you. And the third thing is that we are open for every customer as well. So not only MPS customer, so all other customers as well, and support them as well.
So any more question from the audience? So we have one more. Could you repeat the question then, Jan, please?
Yes.
And are you going to share the result in the future?
Yeah, the question was what measurement method we used here, and if we share the results in the future. Yeah, we use DPI measurement on this. Sharing the measurements is always depending a little bit on the requests, yeah, because it's a lot of effort to do this, yeah, on this. So it's always depending a little bit on the project and on the customer, how they request it on this, yeah, because we cannot do it. We have 5,000 products, so we focus more and more on the products for. I think this is more for automotive, yeah. So for the industrial customers, it's not so often requested, and it's quite difficult because we have much bigger range of products in this direction. But for automotive, it will be quite common if we want or not, yeah, to do this.
So we will select one last question and then we will end this session. So does anyone have another question? So
Extend to this question.
Huh?
How do you choose? I mean, like, how do you characterize if you make a IC? So how do you choose? Should we perform EMC on this IC or not? It's based on completely on customer, or it's based on internal.
At the moment, we are not. As you know, the lab is quite new. Yeah, it means I cannot make everything now. So we're starting on the request of the customers. Yeah, and then for the future, I think it will be more and more for all the products, new products. Yeah, we can do this.
To be more precise to this question, would you be able to also do the measurements if we send our boards, a real application board directly? For example, if I use the MPS chip, I mount the chip, and instead of doing measurements on the evaluation board, they will do it on the real application board with maybe some load.
Yeah. The question was if we can do the measurements in the lab also with a real application, customer application boards, and I need to say yes, definitely. Yeah. So this is what we're doing for certain customers as well. Yeah. So that's not the big deal, but it's always because you know your product, we know our IC, you know your product. So in this case, it's not only shipping the board to us and then saying, hey, I want to have in 2 weeks a full validation. I want to have I have a full optimization and no problems anymore. That's not realistic, yeah, on this. So it's always something you need to support as a customer.
So thank you very much, Jan, for this great presentation. We also had a lot of questions coming in via the online Q&A button. We will answer those questions via email. And during the presentation, a couple of times, the question came up if we will send the presentation slide deck and the recording to the online participants. Yes, you will receive the presentation and the recording via email in the next couple of days. Thank you very much for attending our webinar. We are looking forward if you are also attending our session in the afternoon and the session tomorrow. See you soon.